Okay, I've gotten several requests to get a little bit more of an explanation on the first law problems. What I'm just going to tell you is don't overthink it. I mean, realistically, it doesn't matter what is going on. The key thing is to identify what that system is. So let's say we have a container of a gas here. Now, here's what's going to happen. If you have heat being added into this, however it may happen, have a heating element or something along those lines. But if you have heat going into that, that means that the change in internal energy is going to increase. All right? So in other words, if we have heat in, that is going to be a positive value. If we have an uninsulated container and some of that heat happens to escape, then we have heat out. If that heat is leaving, that means it is going to be a negative number. Now think about what this means physically. We're looking at the change in the total energy that this gas has here. If heat is being added in, that means that the change in energy should increase. If heat is being pulled out, that means the change in internal energy should decrease. So the Q part shouldn't be too difficult to figure out. Literally, if you know how much energy you initially start with, you add on whatever Q adds in there, you subtract out whatever Q goes out of there, and that's pretty much it. Now the work part is a little bit trickier. When we're dealing with the work, well, here, I'll do it on a different box. Let's say that we've got a box with a ceiling fan in it. Now that ceiling fan is going to be powered by an external motor. All right, work is being done. Now here's the thing. We need to identify whether work is being done on the gas or work is being done by the gas. So what you really need to think about is what's going on inside of here. Are the particles inside of here being forced to do something they not normally would be doing? So in this case here, with a ceiling fan, yeah, the air molecules wouldn't normally be blowing around or however inside this room. So what that means is work is being done on the system. So think about it as this. Work is done on the system if particles are forced into abnormal motion. So if work is being done on the system, think about what that's going to do. Work is applying a force that is going to cause some type of displacement. That means that the particles inside of this room are going to have more kinetic energy than they originally would have. So if work is being done on the system, that means that the work value that we are dealing with is going to be a negative. Okay? Now if instead work is being done by the system. Now I'm going to draw an entirely different system here just to make it a little bit clearer. Let's say that we have a piston inside of a car engine. Work is being done by the system if it drives that piston up into the air. Okay? Because of, you take your spark plug, you light the gas on fire, it explodes, and then that piston is going to be moving up into the air. This piston is going to be dealing with abnormal motion. Alright? So what that means is work is being done by the system. If the work is being done by the system, it is going to be a positive work value. Now this all has to do with the fact that we've got a sign convention of the first law literally tells you the change in internal energy equals Q minus W. So work being done by the system is going to give us a positive value. Work being done on the system is going to give us a negative value. Then you just plug it right in here and you're good to go. Alright, now, I know I'm also getting a lot of questions on the system where we've got that cycle, the gas is going through. Key thing is, look at the special cases. You should know something about the amount of work being done in this system right here on the vertical line. You should know something about the total change in internal energy of the system based upon the fact that it is a full cycle. It goes there to there, there to there, and there to there. Use what you know to try to figure out those blanks. Alright? I can't remember. I might have drawn this in reverse, and I apologize if I have. But look at that and think about what is actually going on and what is physically going on. This is not so much mathematically intensive, but it is physics intensive. This is something where you really need to think through what is going on. Okay? So think about what's going on when you go from a, well, low value to a high value over here. What does it mean happens when you go from a low value to a high value over here? Okay? Or go from a high value to a low value, from a high value to a low value. So think about that in terms of the work of the system equals the integral of P dV. Okay? So think about that stuff, try it out, and see what happens. If this didn't help, send me emails, and I will be happy to try to help you out at a future date. I am not going to give any further help on this problem right here until I actually receive your answers. I want you to try first, and then I'm going to do a full video lesson on how this thing works out and how you can predict everything off of it. That will probably be up by Friday morning, so I would really like to have these turned into me at the latest by, let's say, this evening to first thing tomorrow. Good luck, and I hope this helps.